Our next speaker is Richard Foltyn on health dynamics and heterogeneous life expectancies. Richard, the floor is yours. You have 12 minutes.
So thanks for putting this on the program. This is joint work with Jonna Olsson. I should maybe start with a disclaimer. We are both macroeconomists, so this is kind of going to determine how we approach this problem. But I'm delighted to see that it is very intimately related to the second part of today's keynote. So what we are doing is we think we have three contributions. Maybe we are not entirely correct on that. So as I said, macroeconomists, we like Markov chains, and we usually want to calibrate our models to annual frequency. But then we are facing the problem that standard US household panels like the HRS or the PSID are usually at biennial frequencies, and sometimes not even that because there is variation in interview dates or people don't respond to one wave and then they come back. So you have irregular frequencies at which you observe people. And now we're interested in estimating health transitions at annual frequency. By health, I mean self-reported health. And we are also interested in estimating annual survival probability. So what we do methodologically is basically we build a maximum likelihood estimator that can keep track of the latent distribution over health for any period where someone is not observed. And we use this then to provide estimates of survival probabilities and health transition probabilities, and we can then use this to say something about life expectancy, and in particular about the heterogeneity in life expectancy. Here we're going to focus on the health gradient and also on differences across race. So what we find is, of course, very well known to this audience. There is a substantial racial life expectancy gap in the US, but what we can do is we can condition on health, and health in our model is dynamic and evolves over time, so we can even say after conditioning on health and other SES factors, there is still a racial life expectancy gap, and we can further decompose this into the importance of differences in initial health and differences in health dynamics across Black and non-Black Americans. And then in the third part, because we are economists, we kind of want to put a dollar value on this difference in life expectancy, so we choose to do a rather straightforward approach, which is to calculate differences in social security wealth. So think of social security wealth as the discounted present value of the retirement benefits that you're going to receive for the rest of your life. As it turns out, this approximately 3.5 years in life expectancy gap between Black and non-Black Americans amounts to approximately $8,400 more in social security wealth for non-Black Americans, conditioning on other factors. This is also quite related to a recent discussion in the US. If you have been following this, there's been a discussion about reparations, and the life expectancy gap has been the major factor that went into these calculations, but usually these reports find substantially larger figures than what we find. So let me skip the literature. So what we are using is the HRS, which is already what Iñaki alluded to in the keynote, and we are going to partition the sample into Black and non-Black. So Black is anyone who self-reports as being Black or African American. This clumsy term non-Black arises because then it lumps together everyone else. So that's, for example, also Hispanics or Native Americans. And of course, the problem with the sample size is that, well, there is approximately only a sixth of as many Black Americans as non-Black Americans, which kind of creates problems in the econometrics and inflates the standard errors if you care about that. So let me just quickly walk you through the variables. Well, of course, we have age, race, and sex, and also in the HRS you have the date of death, even if someone drops out from the survey, and then we choose to use the self-reported health as a health measure. So this is a categorical variable that takes some values from excellent to poor. Of course, there are problems with self-reported health. On the other hand, we want to embed this into an economic model. We want to estimate a Markov chain, so it's kind of advantageous from our perspective to let the individuals themselves categorize themselves into health states as opposed to, doing a more granular measure that we would have to discretize ourselves to put into our model. So as I said, this maximum likelihood estimator basically operates as a Markov chain on a state space of 5 health states plus death, and then the probabilities just pop out of a multinomial logit. The special thing, as I said, is we are able to keep track of the latent distribution over health states in all periods when we don't observe someone. So that might be the case because someone didn't respond to a particular wave, but then responded to later waves of the survey, or it might be the case because someone stopped responding, but then we know their death date, which was many years in the future. And we run the estimation separately for men and women and for Black and non-Black, so we have 4 different demographic groups. Let me just show you what this estimator spits out. So imagine this person on this left-hand side here. So this is going to be a 50-year-old non-black male and self-reports to be in excellent health at the age of 50. And then we can use our Markov chain to say something about the distribution over health states at arbitrary horizons. So for example, after 10 years, we know that this guy has a 16% probability of still being in the excellent health state. And we can do this, for example, 30 years ahead. And then you see this residual category here, which is the probability of no longer being alive. And you can already see the pretty big gradient in health. So someone who started out in poor health has a probability of being alive after 30 years of only 37%, compared to this guy who started out in excellent health and has a probability of being alive of 50%. So we can then just use this to estimate life expectancy by health. So these are just the averages, averaged over health. This is what you read off the US life tables, but we can disaggregate it by health states. And then, as you would expect, of course, let's say a non-black male who reports to be in excellent health, of course, is estimated to have a larger life expectancy compared to someone who self-reported to be in poor health at the age of 50. The more interesting thing is maybe comparing black and non-black. So if I had a mouse, I would maybe click on this. But there is significant differences across race, even if you condition on health state. So it's not just that the black people are in poorer health. Even if you condition on health, they still have a lower life expectancy. And with our estimator, we can further decompose where this difference comes from. Because we can now say, okay, so we have, for men, we have this 3.5-year gap. For women, we have this 3.8-year gap. And we can, for example, ask the question, so what if at the age of 50, we endow black people with the health distribution of the non-black people at the same age? And then you see the life expectancy would increase by only 0.4 years. So that's approximately 10% of the gap. And then you can ask the question, well, what if we endow them with the health dynamics of the non-black group? Then the life expectancy increases more sizably by 1.2 years for men. And then you can also say, okay, what if we endow them with the non-black mortality? And then life expectancy increases by 1.4 years. So the takeaway from this slide is that the initial health distribution at age 50, as it differs between black and non-black Americans, is not the main driver of differences in life expectancy. Rather, it is these different health dynamics after the age of 50 and differences in mortality conditional on age and health state. We also do this with other covariates, which I don't have time into, but so basically education, marital status, or permanent income. The main takeaway is here that this racial life expectancy gap persists even if you control for one of these. So the estimate is somewhat complicated. We are not able to control for all of these at the same time, but we can take them one at a time. Now, let me get to the economic implications. So as I said, we want to quantify this difference in life expectancy. Maybe the most straightforward and uncontroversial way would be to compute the social security wealth. So what is social security wealth? Well, on the HRS, people report their retirement income, and we just take the average. It's a panel, we just average over whatever they report. And then we want to compute the present discounted value of this stream of retirement income that people are getting in retirement. For that, we just need the survival probabilities at any given age, which is exactly what the model that I just showed you spits out. So this is going to be conditioning on race, sex, health, permanent income, and age. And then we can do this for everyone in the cross-section of the HRS. We take a particular year, 2002, and we compute the social security wealth for everyone in the cross-section of the HRS. And this is then what you find. So this line is the density of social security wealth, which is on the x-axis here, for black people in the HRS, and this is the corresponding line for non-black people. This is for men, this is for women. And unsurprisingly, the non-black one is to the right, so if you just look at the averages, non-black males have a $30,000 higher social security wealth. For women, this gap is a little smaller. But of course, this gap arises due to many factors. It's not just life expectancy. It might be discrimination over their lifetime, for example. It might be different attachments to the labor market. So we want to tease out the fraction that is purely due to differences in life expectancy. How do we do that? Well, in the same way as I decompose this life expectancy gap. So we can, for example, ask what happens to the black social security wealth if we give black people the health dynamics or the mortality of a comparable non-black group. By comparable, I mean same age, same sex, same health, and same permanent income. So this is what I showed you before. if we now do these counterfactual experiments, well, we get a mistake. Okay, so let me not show you the counterfactual distribution. Let me just tell you what it does on average. So on average, if you apply all of these changes to the black population in the HRS, you see on average, Social Security wealth increases by $8,400 for men. For women, it's substantially smaller. Why is it substantially smaller for women? Because the life expectancy gap at older ages, so think 65 plus, between black and non-black women is very small. So that's why these changes in Social Security wealth are small. Now, $8,400 doesn't sound like much, but if you put it in context, so this is a relative change of 13% of Social Security wealth. And maybe more importantly, if you look at what these people report in terms of having net financial wealth, $8,400 is actually 80% of their net financial wealth on average in this survey. So this is, even though it doesn't sound very large, it's actually quite a substantial amount for these people. The last thing, before I conclude, we kind of were interested in the welfare implications of this, and usually when economists are interested in welfare implications, they want to ask the question, so what is the equivalent increase in consumption that you would have to give someone, which is equivalent to this $8,400? So we build a structural model, which I don't have time to go into, but you can think of a life cycle model for retired people, which has a lot of heterogeneity. And then we run these experiments of giving people these, so men, these $8,400 lump sum, when we ask, okay, what is the equivalent increase in consumption every year for the rest of their life? And what you see is for men, these $8,400 are valued the same as a 2.24% increase in their lifetime consumption. For women, again, this is smaller because this life expectancy gap is smaller in the first place. And you see there is some heterogeneity along the permanent income quintiles. Yeah. So just to summarize, we built this maximum likelihood estimator that is able to basically process observations at arbitrary irregular frequencies. We use this to document some new facts in terms of life expectancy along the health dimension and the race dimension, and then we quantify this using a measure of Social Security wealth to show that this is kind of substantial for the black population because they have very little financial wealth. Thank you.